In the second video for geometric series, we're just going to be looking at sigma notation again. So very similar to the arithmetic, but we're just using the nth term of the geometric formula instead. So remember, for expanding, you want to write out each of your terms. So the first term, in this case, we're starting with A1, and we're ending with A5. So we are starting with the first term here. So our first number is going to come from plugging 1 in, which is just going to give us 4. And then if we plug in 2 in for n, we're going to get 8, and then so on. Notice plus signs in between. And once you've plugged in a couple and you're noticing the pattern, because we're multiplying each of these values by 2, you can kind of just do it with the pattern rather than continuing to plug into the formula. Just make sure you've gone from A1 to A5. This is your expanded version. And then you have the option of either just typing it in, finding the sum, or going back in the calculator and using the sigma option. So if we just add up the numbers, we get the sum to be 124. So it's asking you in this question to find both. In our second question, we need to figure out our n. My recommendation here, because it's a little trickier to solve for the n, is to write it out to find your n value. You can do it with solving, and the technique we used with the exponential equations we would use here. So I'll show you that option as well. But a lot of times these are not huge series because the exponential aspect means it grows pretty big. So if I just keep this pattern going, you'll notice I have almost something similar to what I had up top with one extra term. So these are the two that we're missing. But now I'm able to count up my n value, which I'm putting on top. So if you count up, I have 1, 2, 3, 4, 5, 6 terms. So that means my n is 6. My first term here is 2. And my common ratio is also 2, because you're multiplying 2 to the previous term to get to your next term. So for your sigma notation, remember when you're writing it, you always start with n equals 1. And then your final term, how many terms you have, goes on top. And then we'll use our explicit formula, 2 times 2 to the n minus 1. And just like with the arithmetic, technically sometimes those can be simplified, but you don't need to simplify them when you're putting it in sigma. So this would be your sigma. And then if we're finding the sum, again, you could add them up since we have the whole sequence written out or the whole series written out. Or remember, you can do alpha window and do the summation notation here. Oops. And your third option would be to use the sum formula that we did on the first video. Just make sure you keep the entire expression inside that bigger parentheses. And it will give you 126 for that, which if you added up the numbers, it would give you the same thing. Now, let's say I wanted to do this with the formula instead of writing it out, although this one's only technically missing one term. We have A1, we have AN, we don't know our n value. So we would do AN equals A1 times R to the n minus 1. We also see here that our R is equal to 2, because we're multiplying by 2 each time. So we would do 48 equals 3 times 2 to the n minus 1. If we divide this by 3, we get 16. And we can use what we did in our exponent unit. We can make 16 into 2 to the 4th is equal to 2 to the n minus 1. And finish solving that for n. So that would give us 5 is equal to n. But if I just multiply one more time by 2 here, I can also see that I have 5 terms. So you'll notice this number here is never really that big that you can't write out the series. All right, so we now have everything we need for our sigma notation. We start with 1, start with A1, we end with A5. And then our geometric expression is 3 times 2 to the n minus 1. So that will give us our sigma notation. And then we can either plug that in the calculator or add up the terms in the series since we have all of them. So our sum for this would be 93. So the good news is very similar to the arithmetic. This is a little different, but not really necessary since you can a lot of times write out the series as an option.